Anyone still struggling with anything? Okay. We're going to continue on with the next presentation. So, hi, my name's Gesh. I'm an Android engineer from the Hamburg office. I work on the BIS core team, seems to be BIS merchandising team. And in this presentation, I'm going to walk you through some of the standard libraries that are part of the language. Until now, you've learned everything about the language itself, but the Kotlin language comes with a standard library that has a lot of extension functions, which make a lot of the things that we've learned today already much easier to work with, nullability and so on. So one of the first things that we're going to look at is the try with resources. There is no try with resources. In Java, the try with resources is where you put, you use parameterized try and you put your resource in the, directly as a, it looks like a call function to the try, and then they'll automatically get closed for you. Instead of that, in Kotlin, there's an extension function which is called use, and you basically call the function use on any closable, and then in the body of that function, you will be inside a try block. And then you can do whatever you want to do. If there's an exception or anything, it will always make sure to close your closable. The way this looks is basically, this is the Java equivalent of the same call. You would, instead of declaring it inside your try statement, you just directly call use on the file input stream in this case, and then you can use it inside your function with the keyword it. When we talked about lambdas, we didn't mention that, but if your lambda would have a single parameter passed into it, you don't have to give it a name. It will automatically have the name it, and then you can use it throughout your lambda. So in this case, it refers to the file input stream. Another thing that is no longer available in Kotlin is the synchronized keyword. So if you are inside a function, you cannot use the synchronized keyword. Instead, there's an extension function which reads exactly the same as the keyword in Java, but it is actually a function. It's used exactly the same. It will just make sure that this block is being executed only by one thread at a time, enforced on the lock there, which is an object. If you want to have a synchronized method, the way you do that is just you annotate it with the synchronized annotation, and in Java it will create you a synchronized method, same as if you had used the keyword synchronized in Java, but the keyword itself doesn't exist. There is another function called also. You can call it on any object in Kotlin. It basically allows you to call to do some operations, and at the end of the also function, it will return the object on which you invoked it. It's sometimes useful when you do ternary operations, and we're going to see that in when I start coding. But most of the time, I find the function apply to be a bit more useful, and it's the next one that we're going to look at. Yes, this is the this is still way too far. Okay, that's the apply function. The way you use it is basically when you call apply on an object, you pass in a block, and you can execute anything you want in that block, and at the end of the function, it will return the object itself on which you called it. Inside the apply function, this is an extension function with receiver. So inside the function, this refers to the object on which you called it, and that's the only difference between the apply and the also. In case of the also, it refers to the object on which you called it. In the case of apply, this refers to the object on which you called it. So in this case, we're creating just two extension functions, one on the view, on the text view, one on the view, that basically allow you to set the text or the background of the view, and you return actually the same object on which you've invoked it. So in the first case, we'll return a text view. The second one will return the view itself, and we'll just set these things. So you can then use a with a pattern to actually set the text with the text view with some text and with some background, and you can chain these calls as long as you want. It's also quite useful when you build DSLs. The next presentation is going to go a bit more into detail on that. The reason for that is that usually in DSLs you would declare higher order functions which will receive functions with receivers as their input, and it looks something like this to actually invoke them. We'll look at exactly this example in the next presentation. This is just a bit of a taste for what's up to come. The next function is called let. The difference between apply also and let is that let will actually return the output of your of the lambda that you pass it. It's quite useful when you transform data. So in this case, I'm starting with a hash code, I'm adding 5 to it, transforming it into a string. The next operation, drop 1, is actually done on the string that I'm returning. So this will drop the first letter of that string, and then I'm using the let again to actually pass it into another function. In this case, it will basically get some object. It will create a random object, get its hash code, add 5 to it, transform it to a string, drop 1 character from that string, and then print it on the command line. So this is basically a lot of code in Kotlin allows you to just like chain functions like this. This is kind of hard to do in Java. You'd have to have a few variables. You'll have to always pass them around. You'll have these variables which very often come with nonsense names like temp or result or things like that. And being able to just do transformations and just pass in other functions or invert the order in which you call things is quite powerful in Kotlin and allows you to kind of get rid of those useless variables that are dangling around in Java. So the last one was the inversion of control, and that really helps a lot also with nullability. In this case, we had something which is nullable, and we have a function which accepts a non-nullable. And in order to be able to call that function, you have to make a null check. During Kurt's presentation, you saw that basically you can just wrap this function in an if block. But you don't have to do that. You can just use the let function that basically accepts a function itself. So in this case, I'm making a safe call to the let function, and I'm passing in the really show function as the function that I want actually to be executed inside the let. So this will make sure that if maybe is null, it's not going to call anything. If maybe is not null, it will call the really show function, and the really show function accepts any. So it will basically give the maybe into the really show function only if it's not null. So this is the inversion of control that let kind of helps you achieve in just a very short syntax. So instead of creating small if statements that have just one function, you can just use the let. The next function is called run. The only difference between run and let is again the same as with also and apply. The let function is a extension function. The run function is a normal function, which means that inside the lambda, the maybe will be referred to as it. Like in here, I'm not passing in a lambda, but if I was passing a lambda inside the let, in the upper invocation, maybe will be referred to as this inside the lambda. In the second invocation, maybe will be referred to as it inside the lambda. So it's just syntactic sugar. It depends on what really operations you do. So you can use both of these to kind of have a bit more expressive method calls. The next one is called is with accepts a function. So instead of calling it on another object, it accepts 2 arguments. The first one is any object that you want, and the second one is a lambda. Inside that lambda, the object that you pass to with is referred to as this. So the second one is a extension function that acts on the same object that is passed as first argument. This allows you to do some grouping of methods. So if you wanted to do textView.text equals hi, textView.background equals blue, and textView.visibility equals visible, you can say with textView, and then inside the block do all 3 operations. All of these functions are inline functions, so they come with no added runtime any complexity. When they compile, it will be the exact same bytecode as if you call text.view.text, text.view.background, text.view.visibility. It's just a bit nicer code and a bit of nicer way to structure things. The other two are checking for nulls. So sometimes when you receive arguments to a function, you want to make sure that those are, especially when you create APIs that other developers will be using, you want to make sure to enforce some sort of nullability. This is really useful when you work with libraries that have been written in Java, because if they were written in Kotlin, you can just enforce that you accept something to be null or non-null. But if you are extending from, I don't know, any of the other libraries that we're using, which are still written in Java, it might be that the argument is allowed to be null, but for the purpose of your function, that is a wrong state. So there are two of them, and the only difference is that one will throw an illegal state exception, the other one an illegal argument exception. And yeah, they'll return a non-null value. So in this case, for example, I'm checking that the context in a particular function is not null. And in case it's null, I'll throw an illegal state exception because the view in which I am or the state in which currently the application is should actually have this view attached to the view hierarchy, but apparently it's not. And that's a bad state to be in. It's a very, very short presentation because the live coding sessions are going to get a bit longer because we know a lot more about the language now. But any questions on any of these functions? All right, then we'll get on coding. So in this presentation, we're going to create additional classes that will help us actually read from our public API. This is the request I'm interested in, and this is the return value. As you'll see, we already have like a list of businesses, but we haven't declared something that will wrap it and will have a total. So the first thing that we'll do is create another data class that basically wraps around the data class that we already have. So in here, I'm just going to create a new Kotlin class. It's going to be a class, and I'll call it, I think I copied that, I'll call it the business search response. This data class, and it has a val total, which is an integer, and another val, which is our list of businesses. Let's call it just list. Of our business objects. So that's cool. So we have now something that represents this. We have something that represents a very small portion of this, namely just the name and the image URL. And this whole thing is actually called on this API. So I need just a path here to create, if I'm not mistaken, the next one was to create the retrofit API. There you go. So retrofit APIs, all you have to do when you want to create the retrofit APIs, you need to declare an interface. So I'll just say I want an interface, and this will be my business search API. It will be I'll have a function which is called search, and it will take a query of type string, and this will return me a single of my business search response. Yeah, that single. The way you use retrofit, probably know, you basically have a getter and you say, I want to access this. There's a bit more in here, actually. You always have to provide a location and a term. Because We're not going to do location because it's a bit hard. We'll just hard code the location to be San Francisco. This is actually called term, so I'll just call it term. And I'll annotate that this is a query parameter called the term. So with this in here, I can now call this function, and it will return me a single. We still have to create the retrofit API, so I'll go in my repo and basically say, instead of just returning something that is not created, I'll use APIs, which is a fancy class that we can look in a bit, which can instantiate anything, any retrofit interface. So in this case, I want the API, and I want to say search, passing in the search term. And this complains that now we have this single which was returning the list of businesses, but we're not interested in just the list of businesses. We actually want the entire business response. So we'll have to change this bit and say this response is also the business search response. Oops. Cool. So now we're actually doing some network. So we're calling this, and our main fragment will probably be unhappy because this is no longer a list. It doesn't know how to deal with this. It's hard. So instead of doing all this, we'll just say that this here list is actually the response. And we'll have to handle a bit more of the different types of responses. So the first thing that we're going to check is that there's no error. So if response is null, we'll do error, and then we'll return from the subscribe. Now, this is the happy path. In the happy path, we still have to check how many instances of search we have. So in here, we'll make response total, I think we called it, yeah. So this is what it tells us that the total number of responses is. If it's 0, we still want to have this part. So we didn't find anything. If there are more than 1, then we just want to get response.list.first.name. And if I didn't break anything, let me see which function, which app. I'm in app 3. If I run app 3, I should actually be talking to our API now. Cool. So in here, I want to talk. So let's see, what's the #1 result for sushi in San Francisco? Error.
My favorite sushi restaurant.
It's the favorite sushi restaurant. Okay. So that didn't work out as good. So probably what we really want to do is actually get the error and really throw it so that we know what happens. So in here, we'll do something else. We'll say, if error is not null, crash our app. There you go. That crashed the app. And, missing internet permission. We're doing internet. So, I actually don't know what's the internet permission by heart. But this thing here works, and it has the internet permission. And this doesn't. Okay. Test 2. Or 3, for those that are counting. So the #1 sushi restaurant in SF is not working. Let's see what crashed this time. Required value list missing. I called it the wrong thing. For those paying attention, this thing here is called businesses. And in my data classes, I call this list. This is businesses. And then this here is called businesses. Let's try that one more time. The sushi in San Francisco. Oh, so bad. Should have practiced these. And Kotlin JSON adapter from blah, 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 blah. Image URL is missing. This thing here is called image_URL. So our business was called image URL, but we don't want to introduce any underscores into our data classes. So this one is using Moshi, which basically has a nice JSON annotation where we can say, hey, this is actually in our, on the internet, this thing is known as image URL. I have to give it a name, image URL. Cool. I think this should now hopefully work. Let's see. Well, it means that it's at least making the network call because it knows that it should be an image URL and it can't match it. So I think this will be the attempt that will actually show Ryoko's is the most famous sushi restaurant in San Francisco, apparently. Cool, so everything works. The nice thing about all of this is this is my mock repository, and the only difference that I have to change here as well is I'll make this as a real call. This is actually an infix function. And the problem with this was that I'm creating a list of these, but actually what I should be creating now is a business search response that has a total of 1 and a list of test businesses. And if I did everything correctly, I don't have to actually change a thing about this. It should just work. Because I'm just mocking now the correct thing. And if I run these tests, they should still be passing. And they are. So that's everything to change a mock endpoint to actually search our public API. One final warning again. Every single time we call this number here decreases. We have 5,000 attempts. So if you have a public API for any other reason, it would be really nice if you can go into, when you go into the APIs class, oh yeah, I promised you to actually look on this, so let's check this out. It's actually pretty nice. It has this get method, which is an operator. That's how I basically am able to use angle brackets with the class inside to get an interface. And what it does is whenever I try to get any service, it will call the create method. And the create method basically just calls this giant retrofit builder. Does some funky adapters. This is basically the Moshi and RxJava and all of that. And just creates this for us. It has a nice little OKHTTP client, which has a network interceptor, which adds this authorization header, which is basically the API key. So if you can replace this string here with any other API key that you create, just keep the bearer. So it has to be bearer space your client ID. This is like if you've ever created one, this is this string over here, the API key. So if you replace that, then you're not going to consume any of all of ours 5,000 requests, because we have one more demo to go through, and then after that, you can burn it. Thanks a lot, and have fun. If you have any questions, ask us.